Ready? So we start with the box and whisker diagram. Okay? Or we can just say the box plot. We just call it the box plot. So if you see your exam, it could be called the box and whisker diagram. It could be just be called the box plot. I put some IB pass paper. Whenever you see, can you stop writing, please? Whenever you see the number marks allocated for questions, it means that question is from IB pass question. Okay? And if you look at the worksheet that I just passed out, there are 10 questions altogether. You will realize from number 5 to number 10 are all past questions. Now, please focus, please. This box is also, this plot also enables you to visualize the distribution of the data. Okay? And there are 5 main parameters that you will notice that you can deduce from here. So in one of the preliminary questions, I ask you to write a 5-number summary of distribution. When such is requested of you, what we mean is the 5 numbers that can be easily deduced from here, and they are the minimum, the maximum, not in that order anyway. The minimum is here, the maximum is other side, and the median and the quartile, the upper and lower quartiles. So basically, the 3 Q1 to Q3, as well as minimum and maximum, because we all know the median is the middle quartile, right? The second quartile. So this is the 5-number summary that you will see. Now the length here is the whisker, okay? That will be helpful later. The median is usually at the, so we call it the box and whisker because this is the box and this is the whisker in question. Okay? It looks like the column graph. It's a graph that has to do with just column bars. Okay? Something like that. Your pie chart looks like your pie, apparently. Okay? Or it looks like your pizza, which is in the shape of a circular pie, something like that. Anyways, so the minimum will be at this edge here. The maximum will be here. There are conditions. Sometimes the maximum is not included. I'll tell you when. The upper and lower quartile are where the boxes begins and end. The median is the line in the middle. So from any plot like this, any box plot like this, you can always tell us this is the minimum, this is the maximum. Oh, this must be the Q1, this must. So for your interquartile range is simply this, the difference between this and this. Okay? And similarly, if a data is given, all you need to do is figure out these 5 numbers. And that will give you the plot. So you figure out these 5 numbers from any given data. You have a number line in a scale. Of course, the graph will be given. So most of the question I ask in the worksheet, a graph is already given. So you can easily, either a scale of 5, 5, then you know each represents something. So it's not a sketch. Understand? It's a scale. But if I just leave a blank space, you could just maybe rule 1 centimeter, 2 centimeters, something like that. Okay, not too OCD. I'm not saying that Kita don't do OCD, it's fine. Anyway, now, we can, I said something about the minimum and maximum may not be included if the outlier is involved. So at this point, your syllabus asks us to also introduce you to, just a sec, compressed syllabus. I need full attention, Ms. Nakita. Full attention, please. If you look at this section of your syllabus, you have this range of what the outlier in the distribution might be. Outlier is any data that is not within this range, where x is 1.5, so 1.5 plus or minus interquartile of your range is the outlier. Once we calculate that boundary, any data that is not within that boundary is not included in the box plot. We will see that in a bit, so I just wanted to mention that. This is from the syllabus, which is why that is also included. Now, your box plot can tell you, like I said, is the visual representation of your distribution. From another thing we can deduce, apart from deducing the minimum, maximum, interquartile range and all that, remember all these tells you the spread of the data, isn't it? Now when the data spread, is it symmetric? Does it skew to the right? Does it skew to the left? It's another thing entirely. When it's skewed to the right, which is a positive scale, for example, it means most are here, then it's spread towards the side. Am I making sense? Skewed to the left is the opposite. And when it is symmetric, it means mostly in the middle, while there are a little bit towards left and right. Is that not? So there's a way you can deduce that also from your box plot. If you look at this, these two lengths will be the same, and this line will be at the center of the box. In a situation where you notice this, the distribution is symmetric. Again, the whisker will be the same, and the median, which is the line in between the box, will be at the center. Because it's possible this line that is in between your median may not be at the center of the box. Okay? So then you know you are dealing with a symmetric distribution. If it is positive scale, look at the column graph, what it looks like. Now this is what the box plot will look like. The whisker on the right will be greater than the one on the left. Okay? Can you see that? And the median line will be closer to this one. So it's like there is a lot of space here towards the right. If it is the other way around, which is the negative scale, there will be a lot of space on this side. So between the lower quartile and the median will be greater than between the median and the upper quartile for the negative scale. So if you look at positive scale, this way you will see that you have enough more spaces here. Small spaces in the sense that for the gap between the median for the Q2 and Q3, and also for the whisker on this side. And for the other one, it will be the exact opposite. You see here, you have, this is your median, this is the lower quartile, it's more than the other one, and the whisker on the left side is also more. So basically the median is like the point of reference for you. When you check your median as a point of reference, look towards the right. Do you have more in the box and more whisker? If you look towards the right and that is the case, then that is a positive scale distribution. Again, you look at the median of the plot, which is that middle line in the box. Look towards your left. Do you have more space up to the other quartile towards your left? And is the whisker longer on the other side? Then you are dealing with a negative scale distribution. If it is a symmetric distribution, you start from your median. The box is divided in exact half. The whisker are of equal length. Then you are dealing with a distribution that is symmetric. Am I making sense? With this, maybe we can start with this. Okay, I didn't mention outlier. When you calculate your, because I was going to ask you to match something, and the outlier has not been looked into. Mr. Miller is recorded. Could you go through the back, please? If you this is how we check our outlier. The outlier comes in this boundary. Am I making sense? It comes in this boundary. What is the lower boundary? What is the upper boundary? All you have to do is your quartile plus 1.5 times the IQR. IQR is the interquartile range. Okay? So we take the interquartile range times 1.5 and we do plus or minus the quartile. So remember, every distribution has Q1, Q2, and Q3. The space in between this is the interquartile range. Am I making sense? Let's say that is A. Understood? So if you are looking for this boundary, it is simply minus that. So this X is simply our Q1 minus A. This Y is simply our Q3 plus A.
Isn't it times 1.5?
Yeah, I already told you what my A. Oh, I didn't multiply that by 1.5, sorry. 1.5A. I thought I already included 1.5 in my constant. Does that make sense? So once you check this boundary, any number in your data set or your distribution that is not within this boundary is an outlier. And the outliers are not included in the box plot. Okay? So when you discard the outlier from the box plot, the next number within this interval will be this line that we are talking about, will be here. So this number, which is maybe 78, may not be the maximum. Understood? But it is the maximum number within the acceptable boundary. Does that make sense? Now what happens to the maximum number itself in the distribution? We show that by putting asterisk. I'll show you one in a bit. Aha, here is one. So what this means is that this is the outlier that was calculated. This is the maximum number in the data set given, but that falls outside this range. Are you with me? Again, we all understand what the box plots, how it works, isn't it? To interpret it also, to tell us what kind of distribution, we understand that. Now, outlier cannot be indicated among the whisker and the box. But you have to, that means you have to first of all calculate the boundary for as far as that distribution is concerned. First thing you have to do, of course, from your data set, you can find your median, you can find your Q1 and Q3. Otherwise, you don't have the box. You have your minimum, you have your maximum, but don't, don't start immediately. You are welcome to write your box immediately, but then, for your minimum and maximum, check if it falls within the boundary. Okay? Discover your interquartile range, which is the Q3 minus Q1. Multiply it by 1.5. Okay? Once you multiply by 1.5, remove from the Q1. Are there data that are left behind within that range? They are the outlier towards the left. Add it to Q3. Are there data that are not supposed to be included? Then they are the outlier on the other side of it. Understand? If there are data of such, they are not to be included in the whisker. So indicate their position on the plot using asterisk. Okay? Now when you exclude this data, the maximum and the minimum that are included in the boundary determines where this whisker ends. Okay? In some pictures, especially in your past question, this is not just a dot, it is usually a vertical line. Understand? So if you are checking the past question, or you are checking the question that I've printed from number 5 to 10, you might be seeing lines. It doesn't make this any way different. Understand? Let's play one of this. Let me see if I haven't missed anything in my summary. Then we can quickly... Okay, let's look at this one without the outline.
A Box-and-Whisker diagram visually displays a 5-number summary of a data set, including the minimum value, the lower quartile, the median, the upper quartile, and the maximum value. The median is a measure of the center of the data set, and the quartiles and the extreme values give an indication of the spread. Look at the data set in this example. To find its 5-number summary, we start by writing it in order. We can see that the minimum value is 2, and the maximum value is 9. There are n equals 16 data values. N plus 1 is 17. So the median is the average of the 8th and 9th values in the ordered set. In this case, these values are identical, so the median is 5. Each half of the data has 8 values, so the quartiles are the average of the 4th and 5th values in each half. The lower quartile is 2.5, and the upper quartile is 6. To draw a box plot for this data, we start by drawing a number line, which at least includes the range of values in the sum. We draw dots for the minimum and maximum values, then a rectangular box from the lower quartile to the upper quartile, including a vertical line for the median. we draw a straight line between the minimum value and the lower quartile. This is called the lower whisker and represents the lowest 25% of the data. We also draw an upper whisker, which represents the highest 25% of the data. In Part C, the range is the difference between the maximum and minimum values, which is 7. The box from the lower quartile to the upper quartile represents the middle half of the data set, which is the interquartile range. The interquartile range is the upper quartile minus the lower quartile, which is 3.5. In Part D, we use the ordered data set to identify the values less than 3. We see that 4 out of 16 data values are less than 3. This is 25% of the data values.
Does this make sense?
Yes.
So again, I particularly want you to pay attention to this lower whisker and upper whisker. The last 25% and the first 25%. Because we might be linking this to 25th percentile and 75th percentile later. Understood?
Mr. Daniel.
Yes, quickly.
So for the upper and lower whisker, you
Mhm.
take the upper one is Q3 plus 1.5.
No.
No.
That has nothing to do with whisker. I mentioned that for the boundary of the outlier. So are you asking about the outlier or are you asking about the whisker? Or maybe you could just wait while I play the second one. Okay? Because you're mixing two things together now. Your whisker is just a line from your minimum to the box. It has nothing to do with 1.5. Your 1.5 comes in when there are issues with outlier. So listen to this. After this, you are welcome to ask me a question again.
So far, we have informally identified outliers or extraordinary values in a data set
Or
by
extreme
looking
values.
at a graph or at the data directly. Look at the data set in this example. It is not immediately clear whether any of the values are outliers. We can formally test for outliers by calculating the upper and lower boundaries of a set. The upper boundary is the upper quartile of the set plus 1.5 times the interquartile range. The lower boundary is the lower quartile minus 1.5 times the interquartile range. If a data value occurs outside these boundaries, it is considered an outlier. To find the 5-number summary, we start by writing the data set in order. The minimum value is 1, and the maximum value is 16. There are n equals 20 data values. N plus 1 is 21, so the median is the average of the 10th and 11th values in the ordered set. In this case, these values are identical, so the median is 8. Each half of the data has 10 values, so the quartiles are the average of the 5th and 6th values in each half. The lower quartile is 6.5, and the upper quartile is 10. To test for outliers, we first calculate the interquartile range, which is the difference between the upper and lower quartiles.
Randy?
The upper boundary is the upper quartile of the set plus 1.5 times the interquartile range. The result is 15.25. The data value 16 is above the upper boundary, so it is an outlier. The lower boundary is the lower quartile minus 1.5 times the interquartile range. The result is 1.25. The data value 1 is below the lower boundary, so it is an outlier. To draw a box plot for this data, we start by drawing a number line, which at least includes the range of values in the sample. We draw stars to show the outliers. We draw dots for the last values which are not outliers. then a rectangular box from the lower quartile to the upper quartile, including a vertical line for the median. The whiskers are drawn from the quartiles to the last values which are not outliers.
Understand? So your 1.5 is not really depending on your whisker. But once you identify your outlier, then you can talk about how your whisker is. Okay, so I would need you to clarify that. I also want to mention, this data set consists of just 20. Does it mean if you are dealing with 100, you have to list in this order first? No. You might be given a frequency distribution table. So do not forget the I/4 times n plus 1 to determine the position. We mentioned that last lesson. Okay? Let me see if there's any of the... You have a question? Okay, one second. Everybody look at question 9. The last page 4 of your worksheet. Can you see, in that case, you have a frequency distribution table. But luckily, it's already given. The lower quartile and the upper quartile are indicated. What if they are not indicated? Understand? So, if they are not indicated, I/4 times n plus 1. I hope everybody remembers that. So you don't have to list all the time in order to figure out what they are. If you look at question 6, IB question is so nice. Even question 6, you've been given the quartile for this result are 3 and 5. These people are too nice. I wouldn't do that. Not because I'm mean. I might be median or mode. Anyway, what's your question?
So if you use the formula for the n plus 1 divided by 4, if you get a number like 2.25 or like 2.75, you use the, does it count as the second term or the third term? When you get 2.25.
So 2.25 is still telling you is within this particular group of numbers. So it's still within 2 and 3, for example. Okay, so what are the numbers in between, how do I say? Oh wait, you said 2.25. You can't get 2.25.
Yeah,
oh, divided by 4.
Yeah, when you divide.
Oh, I see what you mean. So yeah, it's still within. So let's see, let's use this.
Yeah, but for 10 numbers.
Let's use this. This is 21, right? So let's check n plus 1 divided by 4. Then 3n plus 1 divided by 4. Yes? The position in this case will be 21 divided by 4. The position in this case will be 3 times 21 divided by 4. So what is this? This will be 5.25, yes? And this will be what? 15.75? Can somebody confirm that? I might be dumb in the morning. Okay, so let's see, 5.25. 1, 2, 3, 4, 5. So you see, it's at the center. So this 5.25 is within the 5th position and the 6th position. So you take the 5th and the 6th value, find the average, and that gives you what you need. Again, here, this is within the 15th position and the 16th position. Because positions are in natural numbers, right? So again, let's check. If this is number 20, this will be 19, 18, 17, 16, and 15. You see? What you need is within 10 and 10, so definitely 10 is it. So it doesn't matter whether it is 0.3 or 0.4 or point whatever, that position is within 2 integer positions. And those were the things you consider.
So when you get like 10 values, when you find the third quartile, you get like 8.25.
What do you mean?
Like,
You mean, are you talking about position or the value itself?
Position.
Position. So if it is 8.25, that position is within which
8
position?
and
8 and 9. So pick the 8th item, pick the 9th item, find their average.
But if you listed out like 10 values, shouldn't it be between 7 and 8?
But you just said 10 value, your position is 8 point something.
Yeah. But if you listed out like that, shouldn't...
In that case, if you have 10 values, you cannot get 8 point something. Because your upper quarter is the 77.5th percentile. So for 10 value, it's going to be 10 plus 1 divided by 4, right? Then 10 plus 1 times 3 divided by 4. So check. You can't get the 8 point something, did you?
You get 8.25.
This is 8.25?
Yeah.
And this is what?
2.75.
3 point?
2.75.
So this is within the second and third. This is within the 8 and 9.
But shouldn't it be 7 and 8?
No, I don't think so. So let's see. Let's pick 10 items. Maybe A1, A2, A3, A4, A5. I get what you mean. A6, A7, A8, A9, and A10. So my median is here, right?
Mm-hmm.
So my quartile will be,
Yeah.
yes? And this will be here, right?
Yes.
So this is my lower quartile. So 2.75 is actually between 2 and 3.
Yeah.
You have a point there. And the upper quartile is actually the 8th item. You have a point there.
Wait.
This is a good observation. Because when we say the 75th, oh wait.
8 and 9.
No, because 10 is an even number, isn't it?
Yeah.
So yeah, this is our Q3. This is our Q2. This is our Q1.
Or is it because the Q2 is 5.5 but not 5?
What do you mean 5.5?
So it should be like A1 and A5.5 for the lower range.
No. If I get you correctly, our Q2, because they are 10, is 10 plus 1 divided by 2, isn't it? Which is the same as 2 over 4, like that. And that is 5.5.
Yeah.
So 5.5 is exactly here.
Uh-huh.
So that makes sense.
Uh-huh.
But for this one,
I
well,
think
if you also look at the median of this,
Mhm.
you realize you're in the 8.
Or is it like, because it should be between 5.5 and 10 and not like 6 and 10.
No. This, say that again.
It should be between 5.5 and 10, but not 6 and 10. So
What do you mean between 5.5 and 10?
because the middle is 5.5. So you
Because
can't
your
count.
A3 is the median for A6 and A10, not for 5.5 and
Yeah.
A10.
I didn't get that.
Because we're confused because the A8 is the median, right?
Yes.
It's like, but then we're actually finding the median between 5.5 and A10,
Yeah.
and not A6 and A10.
Oh yeah, so median between 5.5 and 10. But I'm also looking at it from the beginning. Remember, you have your...
That's your A1 to your A5.5.
Wait, does this divide distribution into 4 equal parts?
No, right?
I think it does. Because from here, you have, can you see?
Yes.
Equal part, 2, 2, 2, 2.
Oh, yeah.
That's the whole point of quartile. Decimal will divide into 10, quartile will divide into 4, percentile will divide into 100. So when you draw this line, you see 2 here, 2 here, 2 here, 2 here, 4 equal parts. So these are the median. So I think we might want to kind of limit cases where we apply this. If we have simple cases this way, maybe we might want to look at how it is in this form. Or better still, once you identify, Lillian said something and I think I quite agree, you might want to look at, okay, if your position of median is 5.5 and the position of this is 10, so the next center will be in between them. Okay? So in between these two will be
8.25.
8 point what?
25. Like how you calculate it.
No, this is actually position 8. Position 8 is your median because these are the number. This number represents the position. If there are 10, position 8 is your upper quarter. Do you understand that? I will have a look into this and come up with a general scenario. But if you have a list of numbers, it's easy to pick from there. But if you have the frequency distribution table, please, you might want to consider it because if you have a larger data set. Understand? Maybe that's one of the reasons the IB pass question already gives you the quarter, so to avoid any kind of ambiguous situation. Okay? All right. Having done this, I'll look into that. That's a very good observation. So let's start with what's identifying the distribution. So I'll hand this over to, let's see, okay, let's take this for your table. 3, are those 3 or more? 3, okay.
One.
So give it to them at the back. I want to believe this is 4. Everybody turn to the first page of this. You have a column diagram for certain set of data, for some data set. You have to match. Okay, do not find the upper boundary or whatever boundary from the properties that we have just discussed. Try to draw a line to match. Which of these pictures, which of this column diagram represents the box plot on the left? Okay, on the right, I mean. Understand my point?
Yeah.
So match them quickly. So look at it. Based on certain properties that we have talked about. Remember, consider the outlier factor. I want you to also consider the symmetric property of the